Hi everyone, I am Karthika and this project is part of IDC 14 Days Databricks and AI Challenge conducted by Indian Data Club in collaboration with Code Basics and sponsored by Databricks. In this project, I worked on end-to-end e-commerce user segmentation using Databricks and machine learning. The goal of the project is simple: to understand user behavior from large-scale data and convert the data into meaningful insight. I will walk you through the complete workflow, starting from raw data ingestion, moving through data engineering using Medallion architecture, applying machine learning for user segmentation, and finally presenting insights through interactive dashboard. For this project, I use a real-world e-commerce behavior dataset from Kaggle, originally created as part of OpenCPD project. The dataset contains around 285 million user events collected over 7 months from October 2019 to April 2020. Each row is the dataset represent a single user action on website, such as viewing a product, adding product to cart, removing product from cart, or completing a purchase. Because of large-scale event based on nature of the data, traditional tools are not enough. That's why this data is well suited for Databricks and distributed data processing. The core problem I try to solve here is how we convert millions of raw user data into clear user segments that help business understand behavior and take decisions. An e-commerce platform may have millions of users, but not all users behave the same way. Treating every user equally leads to insufficient marketing, poor targeting, and missed revenue opportunities. So the objective of the project is to segment users based on their behavior, to identify high-value customer, understanding browser versus purchase pattern, and support data-driven business decision. This slide shows the end-to-end workflow of my project. The raw data is first uploaded on Amazon S3 and then processed in Databricks using the Medallion architecture, bronze, silver, and gold layer. The bronze layer stores raw data. The silver layer handles cleaning and transformation, and the gold layer serves a single source of truth for an analytics and machine learning. On top of gold layer, I applied machine learning for user segmentation and finally built dashboards for business insights. Data ingestion. The dataset size was very large and I could not upload it directly to Databricks. The files are GB scale and direct upload was either very slow or failing. So I created AWS S3 bucket. Even there, normal upload was slow and unreliable. To solve this, I use AWS CLI, which is faster and more reliable for large file uploads. These were the commands I use. I use ChatGPT for this. After uploading data to S3, I connected S3 data to Databricks using external location. This S3 data then become my raw data source, which I use for further processing in bronze layer. Medallion architecture is layered data design used in Databricks to improve data quality, reliability, and scalability. It organized data into 3 layers: bronze, silver, and gold. In the bronze layer, I created a bronze schema and read the raw data from S3 into data frame. No transformation were applied. I stored the data as delta table called raw events. In the silver layer, I created silver schema and read data from the bronze layer. I performed data type casting, minimal null handling, filter to only valid event types, and added derived columns like event time and is purchased. The clean data was stored as events clean delta table. In the gold layer, I created business-ready dataset using silver data. I built 3 gold tables: daily sales metrics, product performance, and user behavior metrics. These tables are used for dashboards and machine learning. To automate the pipeline, I created Databricks job for bronze to silver, silver to gold flow. These jobs run automatically, making the workflow repeatable, production ready, and reduce manual intervention. The goal of the machine learning part is to segment user based on their behavior, so the business can understand different types of customer. I used gold layer user level data with features like total event purchase count and total spent amount. Since there was no predefined label, I used unsupervised learning. I selected k-mean clustering because it's simple, scalable, and works well for behavior-based segmentation on large dataset. To manage experiment, I use MLflow to track parameters, metrics, and model version, making the ML process reproducible and well organized. The final output is clear user segment that can directly used for business analysis and dashboard. After generating user segment, I saved the ML predictions back into gold layer. This step connects machine learning output with dashboards and analytics, enabling end-to-end data end-to-end data to AI workflow and direct business reporting. To convert data and machine learning output into actionable insights, I built 2 Databricks dashboard using gold layer and ML results. This was the first dashboard created using gold dataset. This dashboard provides high-level view of business performance using gold data. It tracks total revenue, total product, user activity, daily revenue trends, and top revenue generating product, helping stakeholders quickly assess overall business health. This was the second dashboard created using ML output user segmentation dashboard. This dashboard visualizes a user segment generated by ML model. It shows segment distribution, revenue contributed, and engagement difference, making it easy to compare how each user segment behave and contribute to the business. One key insight is the revenue is not evenly distributed across users. A very small segment of high value loyal customer contributes the majority of the revenue. At the same time, browsers and non-converters form the largest user group but generate low revenue. Another important insight is that engagement does not always mean high revenue, highlighting a clear engagement to conversion gap. Based on these insights, I recommend retaining high value customers through loyalty program and personalized offer. Second, converting browsers into buyers using targeted discount, cart reminders, and better recommendation. Finally, optimize marketing spend by focusing budgets on high impact user segment instead of blanket marketing campaign. So, in short, this project taught me one important lesson: not all users are equal, And not all clicks makes money. Some users just browse a lot and some users quietly pay all the bills. Thank you Code Basics, Indian Data Club and Databricks for assigning this challenge and giving me the opportunity to work on real world end-to-end data and AI project. It was a great experience. Thank you.